Okay. The two concepts that we're going to be going over today is how to solve an absolute value equation and how to solve equations containing two or more absolute values. So the first concept, solving absolute value equations. Defining an absolute value equation, we have the equation that looks like this form. The absolute value of x is equal to a. Just remember, if you take the absolute value of a number, that number turns positive. So if it was negative, it turns positive. If it was already positive, then it stays positive. It says if a is a real number, then if a is greater than or equal to 0, so a positive value, the solutions to the absolute value of x equals a is going to be x equals a or x equals negative a. So this is stating that if a is positive, these are our two possible answers. Positive a or negative a. If a is negative, then the answer is no solution. Okay. So if a is positive, we have two possible answers, a positive and a negative value. If a is negative, then we have no solution for the problem. Okay. So let's look at some of these examples here. Okay, so we have x, the absolute value of x is equal to 5. Is 5 positive or negative? Positive. So that means we're going to have two answers, and those answers are going to be what? X equals positive 5 and x equals negative 5. Remember, if our a value, that number that it's equal to, is positive, our two answers are the positive value of a and the negative value of a. So if we were writing that as a solution set, it would be negative 5, comma 5 in those curly brackets. And we are able to say that because our absolute value is by itself. On number 2, we have the absolute value of w minus 2 is equal to 12. So before we can find the answers for w, what are we going to have to do with that minus 2? Add it to both sides. So we get the absolute value of w is equal to 12 plus 2, which is 14. Okay. 14, is that positive or negative? Positive. So that means I'm going to have my two answers of w equals 14 and negative 14. And I write that as a solution set of negative 14 to positive 14 in those curly brackets. Always start with my negative number, then my positive number. What if I have my absolute value equal to 0? How many answers am I going to have? 1, because can I have a negative 0 and a positive 0? No, I just have 1 0. So this is p is equal to 0. So I would just write the solution set, curly bracket, 0, curly bracket. What about number 4? Our absolute value is by itself, but it's equal to what? A negative number. So what is the answer to this if it's equal to a negative number? No solution. No solution. Remember, we cannot have an absolute value equal to a negative number because what does the absolute value do to a problem? Makes it positive. So that's impossible for our absolute value to be equal to a negative number. Okay. Any questions so far? Okay.
And with the answers here, you specifically want the curly brackets?
Yes, and I believe that's also how they'll have you put it in Alex. Okay. Okay. Now we're going to look at a little bit more complex version of these absolute value equations. And in that red box at the top, it gives us some steps that we can follow. So the first step, it says to isolate the absolute value. Okay, isolate the absolute value. So we were already doing that in the first couple examples where we made sure the absolute value was by itself. Then it says if A is negative, the answer is no solution. So we already know that part. If A is positive, we're going to rewrite the equation where we write our answer as x equals a positive A and x equals a negative A. So we rewrite the equation. Okay. We solve for the individual equations. And then we check our answers to see if they are correct. So looking at number 5, right away we see that we have an absolute value by itself. So that first step is done. It is equal to 5. Is 5 positive or negative? Positive. So that means we are going to take our answer and write it 2 ways. We are going to write this as 2w minus 3 equals positive 5. And 2w minus 3 equals negative 5. So the same thing we were doing in the first 4 problems, but now instead of just having that one variable, we have to write everything inside of the absolute value bars. Okay. Now we just solve like normal. So on the first one, we're going to add the 3 over, and we get 2w is equal to 8. Divide by 2, and we get w is equal to 4. Now we're going to do the same thing to the other side. I'm going to add 3, and I get 2w is equal to negative 2. Divide by 2, and I get w is equal to negative 1. Before I can say these are my answers, I need to plug them back in and check. So first I'm going to check when w is equal to 4. So anywhere I see a w, I'm going to plug in that 4. So I have the absolute value of 2 times 4 minus 3, close absolute value, equals 5. So simplifying this, I have the absolute value of 8 minus 3 equals 5. Absolute value of 5 equals 5. Is this true or false? True. True. So that means w equals 4 is an answer. Now I'm going to check w is equal to negative 1. So I'm plugging in negative 1 now. So when I simplify this, 2 times negative 1 is negative 2. Negative 2 plus negative 3 is negative 5. So the absolute value of negative 5 equals 5. True or false? True. True, because what does the absolute value do? Turns it positive. So that means these are both my answers. And I would write this as the solution set negative 1, 4. If only one of those statements were true and the other was false, that means I would only have one answer instead of 2. Okay. So looking at number 6, we have the absolute value of 2c minus 5 plus 6 equals 2. What is our first step? Good. Isolate the absolute value. So what do I need to move over to the other side?
6.
Good. So I'm going to subtract 6 over. I have the absolute value of 2c minus 5 is equal to negative 4. So am I going to be splitting this into 2 equations? Or am I going to say that the answer is no solution? No solution. Why? Good, because we have an absolute value that is equal to a negative number, and we cannot have that. Let me write that off to the side. Can't have an absolute value equal to a negative number. So once we isolate our absolute value, if it's equal to a negative number, automatically no solution. Okay. Number 7, what would we have to do first to isolate our absolute value? Add the 7, because notice we have a negative 2 being multiplied, and then we have that 7 being subtracted. So first I'm going to add the 7, and I'm left with negative 2 times the absolute value of 2/5 p plus 3 is equal to negative 12. What's the next step? Because my absolute value is not isolated yet. Divide by negative 2. And I get absolute value of 2/5 p plus 3 is equal to 6. Is it equal to a positive or negative number?
Positive.
Positive. So am I going to be writing this twice?
Yes.
Yes. So 2/5 p plus 3 is equal to 6. And 2/5 p plus 3 is equal to negative 6. I write it 2 times because I got a positive a value. Now I'm solving for p in each one, and then I'm going to plug my answer back in to see if they're correct. So for the first one, I'm subtracting 3, and I get 2/5 p is equal to positive 3. What would I multiply both sides by to get rid of that 2/5? 5 over 2 would completely cancel it out. So if you did the 5, you would still be able to later divide by 2. Okay, so if I multiply both sides by 5 over 2, this is going to cancel. And I am left with p is equal to 15 over 2. So that's my first one. Remember, this is 3 over 1. Okay, and I'm just going to go ahead and leave them as fractions. On the next one, I'm going to subtract 3, and I get 2/5 p is equal to negative 9. What am I multiplying both sides by to get p by itself? Good, 5 over 2. That cancels out that 2/5. And then I have negative 45 over 2. Again, just leaving them as fractions. Can I automatically say this is my answer?
No.
No, what do I have to do next? Plug everything back in. So off to the side. I'm going to be first checking p is equal to 15 halves. So I have negative 2 absolute value of 2/5 times 15 halves plus 3 minus 7 equals negative 19. So I need to see if this will give me a true statement. Okay. When I multiply 2/5 by 15 halves, these 2's cancel out, and I'm left with 15 over 5, which is, what's 15 divided by 5? 3. So I have negative 2 absolute value of 3 plus 3 minus 7 equals negative 19. Which leaves me with negative 2 times 6 minus 7 equals negative 19. Because I had 3 plus 3 inside the absolute values, which I'm getting 6, and going to be multiplying by that negative 2. So I have negative 12 minus 7 equals negative 19, which gives me negative 19 equals negative 19. True or false? True, so that means this P equals 15 halves is indeed a correct answer. Now I'm going to check P is equal to negative 45 halves, and I'm going to do the same thing. I'm just first rewriting everything with my new P value. Same thing's happening here, that 2/5 times negative 45 halves, the 2's cancel, and I'm left with negative 45 divided by 5, which is what? Negative 9. Negative 9 plus 3 is negative 6, but the absolute value of negative 6 is what? Positive 6. So notice I end up with the same equation I did before. So I get negative 19 is equal to negative 19, which is true or false? True. So that means this is also an answer. So writing my solution set, I have negative 45 halves, comma, 15 halves in those curly brackets. And this is my answer. Remember, we always have to plug back in and check because there will be a possibility sometimes that one of these answers do not work. Okay, any questions so far? Now looking at number 8, what is the first thing we need to do?
Isolate.
Good. Isolate. Get the absolute value by itself. So what's in the way? What are we going to move over? Good. So I'm going to subtract that 6.9. And I am left with the absolute value of 4.1 minus P is equal to what? 0. I just rewrote my absolute value on the left side. So since it is equal to 0, is 0 either positive or negative?
No.
No, so that means I'm going to write whatever is inside of my absolute value, and I'm going to set it equal to what? 0. 4.1 minus P equals 0. Because I can't say equals negative 0 equals positive 0. I just write 1 equals 0. Now I need to get P by itself, so I'm going to subtract 4.1. And I get negative P is equal to negative 4.1. And then divide both sides by negative 1. I get P is equal to 4.1. Once I find my answer, what do? Plug it back in. So I have 6.9 equals the absolute value of 4.1 minus 4.1 plus 6.9. What happens to the inside right here of this absolute value? Equals 0. So I'm left with 6.9 equals 0 plus 6.9. Which means 6.9 is equal to 6.9. True or false? True, so that means this is my answer, and I write it in the curly brackets, 4.1. So the most important thing to remember here is that if you have an equation with the absolute value, before you solve, you need to isolate it, and you have to make sure your A value is positive. because if your A value is negative, it's no solution. Any questions about concept 1?
How do we know when to use a solution set versus just an equal? Because like I felt like when we were doing radicals, we would have like this variable equals this or this.
Mm-hmm.
So we would write it that way as opposed to the solution set.
Either's correct. They're all correct for every single one. It's just I'm noticing Alex is making you do it like this, so that's why I'm doing like this on the notes. But it's all the same thing. If I was just to write p is equal to 15 halves and p is equal to negative 45 halves, that's the same as writing it in the solution set.
Okay.
Okay, concept 2. So now instead of just dealing with one absolute value, we're going to be dealing with more than one absolute value. So right here in this red box, it says if we have two absolute values that are equal to each other, this implies that the first absolute value is equal to the positive version and the negative version. So similar to what we were doing above. So if we have two absolute values equal to each other, we take whatever's inside the first absolute value, set it to the positive version, and then the negative version. So looking at number 9, we have two absolute values equal to each other, and we would write this as 2w minus 3 is equal to positive 5w plus 1, and 2w minus 3 is equal to negative 5w plus 1. Notice how I put that 5w plus 1 in parentheses because that negative is going to go to every term, not just that first term. So once we have them equal to a positive and then one equal to a negative, then we're going to go ahead and solve for each. So on the first one, we need to get our w's to one side and our numbers to the other. So I'm going to go ahead and subtract 5w over, and I get negative 3w minus 3 is equal to 1. Then I'm going to add the 3 over to the other side, and I get negative 3w is equal to 4. And then divide both sides by negative 3, and I get w is equal to negative 4/3. Remember, just leaving everything in fraction form. Then we're going to do the same thing to the other equation, but before I do that, what am I going to have to do with that negative? Distribute. So it's going to change the sign of each of these. So I have 2w minus 3 is equal to negative 5w minus 1. And again, I'm going to do the same thing. Get my w's to one side and my numbers to the other. So I'm going to add 5w over, and I get 7w minus 3 is equal to negative 1. Then I'm going to move my numbers over to the other side by adding 3. And I get 7w is equal to 2. And then divide both sides by 7, and I get w is equal to 2/7. Okay. Before I can say that these are my answers, I need to plug them back in. So let me move that over. So I'm going to check that first one, that negative 4/3. So I have the absolute value of 2 times negative 4/3 minus 3. 1 minute. I just need to zoom in some more. Okay. So I'm just rewriting this negative 4/3 anywhere I see a W. Okay. And then I'm solving. So I have 2 times negative 4/3, which is negative 8/3, minus 3, is equal to 5 times negative 4/3, which is negative 20/3 plus 1. Okay. Before I can combine these fractions, what am I going to have to do to that negative 3 and that positive 1? Turn them into...
Wait, what'd you say? What was it?
So first I'm going to put these over 1 because I want them as fractions. Now that they're fractions, I want common denominators. So what would be the common denominator in both of these? 3. So I'm going to multiply this one by 3, top and bottom, and then this one by 3, top and bottom. So then I have negative 8/3 minus 9/3 is equal to negative 20/3 plus 3/3. Okay. Negative 8 minus 9 is what? Negative 17/3. And negative 20 plus 3, 18/3. Is this a true statement? Yes, because if we took the absolute value of both sides, we would get 17/3 is equal to 17/3. So this is a possibility. Okay. So we checked one, now we have to check the other. Try to just do it in the same spot. Okay, so I have absolute value of 2 times 2/7 minus 3 equals absolute value of 5 times 2/7 plus 1. 2 times 2/7 is 4/7, so I have 4/7 minus 3. And 5 times 2/7 is 10/7 plus 1. The common denominator here is what? 7. So I'm going to multiply those second fractions by 7, top and bottom. So I get 4/7 minus 21/7 and 10/7 plus 7/7. Okay. 4 minus 21 is negative 17/7 is equal to 10 plus 7, which is 17/7. True or false?
True.
True, because what happens to that first fraction? It's going to turn positive, so this is true. Which means my answer is negative 4/3, 2/7. So the thing that takes the longest here, I feel like, is just plugging everything back in to check. Okay, and then last problem here. We have our absolute value equal to another absolute value. So what would be our first step?
Write it to a positive x plus 8 as well as a negative x plus 8.
Good, we're going to write this equation 2 times. So x minus 4 is equal to positive x plus 8. And x minus 4 is equal to negative x plus 8. Notice how I put that negative in front of the parentheses because that negative is going to go to every term. Now I'm going to solve for x in each one. So on this first one, I need to get all the x's to one side. So I'm going to subtract x over. And then these x's are going to do what? Cancel. So that means I am left with negative 4 is equal to 8. Is that true or false? False. This is a false statement. Because this is a false statement, that means we're only going to have one possible answer instead of two. So now we ignore that first part. That gave us a false solution. So we're going to go and simplify the other equation. So before I get all my x's to one side and my numbers to the other, I'm going to have to distribute that negative. So I get x minus 4 is equal to negative x minus 8. And then I'm going to do the same thing. Move all my x's to one side. So I have x plus x, which is 2x minus 4 equals negative 8. Then I'm going to add 4 to the other side, and I get 2x is equal to negative 4, which means my x value is going to be what? Negative 2. I still need to check if that negative 2 gives me a true statement. So I have absolute value of negative 2 minus 4 equals absolute value of negative 2 plus 8. So negative 2 minus 4 gives me what? Negative 6. And then negative 2 plus 8 gives me what? Positive 6. Absolute value of negative 6 is 6. Absolute value of positive 6 is 6. So this is true or false? True. So that means I have one solution, and that solution is negative 2.